I will copy this part. Just a second. Uh, okay, so I am copying this part. Why? Because if we are deleting the first matching element, now if the element is found at the head only, so that is the situation if the position is 0 also. So that's why I am copying this here. So this will be almost similar. Now we are taking temp is equal to head, and I will use a for loop only. Okay, since we have used for loop earlier, so you can see we have to reach at a particular position, but we are going -1. So later we can update that using this statement that temp dot next is equal to temp dot next dot next. So while iterating, we will reach the node which we one node previous to that particular index. Now we can check if this temp is equal to null or temp dot next is equal to null. We can simply return. Otherwise, what we can do? We can do temp dot next is equal to temp dot next dot next. What does this mean? So this mean I hope you all know this thing. So this is head. This is one node. This is one node. This is one node, and this is pointing to null. Suppose if the temp is this one is temp. Okay, this is found. So no, we have covered head dot head in the if situation only. Suppose if this is temp, so what we can do? We can change temp dot next is equal to the next of where temp dot next is pointing means this is temp dot next. Okay, this is temp dot next. So we are going to temp dot next dot next, that is to null. Or otherwise, if we have nodes here also, so it would be pointing to that node. Now, if this is not null, suppose if this is not null, you have to change the previous reference also. Okay, so we have to change the previous reference also. So what I'm going to do, I'm just adding a statement that if this temp dot next, so let us do if it is equal to null. If it is equal to null, it means what? That temp is the last node. Yes or no? If it is equal to null, it means temp is the last node. So we can update the tail as what? We can update the tail as temp. Okay, this is making sense, I hope. Otherwise, what we can do? We can do temp dot next dot previous. Just now we have discussed this. We have to change the previous node and it should be pointing to temp. This is how we can eliminate this particular node from here. So this is how we can delete at a particular index. Okay, so if you will go to the code again, or if you will go to this recordings again. So okay, if you will go to the code again, if you found any problem, you can go to the recordings again. I hope that it will be very much clear if you just observe the code once after the class. So now let us go for searching part. You can see just with few changes because changes are why because of the previous nodes. So by adding few changes, we are obtaining the double linked list functions. Now for searching an element, now do I need to change this code? Tell me. Is there any need to change this code for searching an element? If no, tell me why. If your answer is no, tell me why. See, just check this code. Is there any need to change this code? No. Now, why the answer is no? You can see the double linked list is having a single linked list in itself. Yes or no? If we don't consider the previous nodes, so we can simply do it as we used to do it in a single linked list. We can iterate from front to back, and we can match the elements. If the key is matching with any of the node, we can say that found at index, and we are using the count variable, not value which we did in the single linked list, and we can increment along traversing. You can see along traversing we are incrementing the count. So this we have already discussed. So for saving time, I'm not discussing this. You can see the head is null. We are just printing not found. Otherwise, we are taking a reference temp and count 0, and we are traversing. If it is matching with the data, this loop will stop. And if it temp is null, it means what? We have reached the last node and the data is not found. Otherwise, in all other situations, we are going to print the count, that is the index at where it is found. Now for traversing the linked list, so this is what? This is forward traversing. Now do I need to change this code also? What about others? For forward traversing, do I need to change this node, this code? You can see temp will stop when it is pointing to null. So we all know that last node is pointing to null. Yes or no? Okay. Now tell me, I want to write a code for reverse traversing. So you have to tell me what will be the change in this code. Okay, I'm just copying this code and there is a one change in this code. So let me write a reverse traversing the list, and I'm calling this function as public void and reverse print. Let me, okay, I'm clicking the comment, just a second. Okay, so no one can tell what is the thing we have which we have to do. So you can see while forward traversing, let me see how many all of you are present in the class. I can see 16 students. Okay, temp is equal to tape. Yes, Jasmeet, you are very much correct. Good job. So you can see while forward traversing, we have started from temp is equal to head. So we while reverse traversing, what we have to do? We have to start from tail only. So I'm taking temp is equal to tail. Now it will stop when we reach the null. Okay, because in previous nodes also the last node is pointing to null, so it will stop when we reach till null. And what we have to do in every step, we have to update temp with what? So while forward traversing, we were doing temp is equal to temp dot next. So in reverse traversing, we will do temp is equal to temp dot previous. So this next I'm just changing with previous. So I hope that you all understood this, that this is reverse traversing. Now I think our code is complete. Let me add this function for reverse traversing here in 7th section, case 7, that is li dot, where is the reverse print? Reverse print. And we are having a break. So now let us see if it works fine or not. So this is, okay, this is running symbol circular. Let me stop this. You have to run this level. Let me check if I have changed the object creation or not. Yes, I have changed this. So I'm running the main block. So let us insert some elements. So let us insert 1. So we have inserted 2. Let us insert 3 and 4 and 5. Now it will print what? It will print in reverse because we have inserted at front. So in front, you can see we are having 5, 4, 3, 2. Now if I press 7, it should print 2, 3, 4, 5. Yes or no? Because it will traverse from tail. So let us check if it works or not. So if I am pressing 7, yes, it is printing 2, 3, 4, 5. And now all the operations will be working in the similar manner. Okay, you can check that later. I am moving to the next operation, that is double circular linked list. So before that, let us discuss the complexity. And before discussing the complexity, just tell me if you have any confusion in this code. Just check this code. Okay, I'm scrolling from top. I'm keeping 1 minute in every function. Just see it. Okay, everyone just see. So this is the node part. We have taken 3 variables. Okay, this, let me show you insert function. So see insert function, everyone. Insert at front. Any doubt? Okay, now I'm scrolling. See insert at end. Okay, take a quick look. Don't go deeper. If you found something suspicious, just tell me. Okay, now see insert after. So this is a bigger function. So take time to see this. Hi. Give me yes or no. Is it fine? If you are not replying here, I mean it is fine to you. So this is delete first matching element. and this is deleting at a particular index. So here also we are just, if the position is 0, we are doing the same thing. Otherwise we are traversing till the one less element, and if any of this is null, if the temp is null or temp.next is null, we can return. It means what, the element is not, the index is not found. Otherwise we can perform these operations. Okay, so now this is searching. So searching was similar, and traversing also, I think there is no confusion. So now let us move to the complexity part and quickly discuss the time complexity. So we have done these things. So now yes, tell me the complexity for creation. Just a second, let me check. Yes, we have done reverse traversing also. Yes. So for creation, the complexity is big of 1 and space will be big of 1. The things will be almost similar. And for insertion, it will be n. So you can see this will be always n. Searching, traversing, deletion of a node, this will be n. Now deletion of linked list in some, okay, let me write here 1. So this is obvious, this should be 1. Now in some of the code, you will see that deletion of linked list or double linked list is big of n. So why it is big of n? So what they are doing, okay, they are going to every node and they are deallocating this previous as well as null. But in some of the codes, you can see they will just deallocate the main object as null. What I am doing, I am just deallocating the main object. So now what will happen? All that nodes will be collected by the garbage collector. So we can do it in big of 1 and space will be also big of 1. So there are many good problems. Okay, so let me show you one kind of problem. So there is a problem like you have a linked list like this. Okay, so I am talking about single linked list. Just now I have realized this was a question which was asked in a company. So tell me the logic which you are going to use. Okay, so this is one linked list. This is pointing to null, and you have another linked list. Okay. So now my question to you is, yes. So these are having some values. Okay. So let us take some values like 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now my question is to you is that you are given with two linked lists. We are intersecting at some point. Okay. So these two linked lists, you can see we are having head 1. So if you are given with head 1, you can easily traverse that list. Yes or no? You can traverse from head and you can reach the null. In the same way, if you are given with the second head 2, you can traverse that list. Okay. So you can see in our code, the functions which we have created, we can pass another parameter as head, and using that head we can traverse. But since we already have the head in the class, we are not taking that head reference. But in some codes you will see you can create functions where you can accept the head. So suppose you are accepting this head and you are accepting this head. Now you have to find the data stored at the intersecting node. So you can see this is what, this is the intersecting node. Tell me what is the logic which you are going to follow. Okay, I don't need the code, just tell me the logic which you can follow. You have to give me the data of the intersecting node. This is a very interesting problem. Anyone? Are you getting the question? If you are not getting the question, just tell me, I will repeat it for you. Give me yes, no at least. Repeat. See, you are given with two linked lists. Okay. So you are giving, if I say you are given with two heads, that is node head 1 and node head 2. And you have to find the intersecting node of these two linked lists. Two nodes containing same reference. Can you elaborate, Monu? Okay, so how you can check that? Okay, I got it, what you are trying to tell. So Monu is trying to tell we have to search for that particular node which is having two reference. Now, is there any way to check that? Can you check for a node which nodes are landing upon it? So no, you cannot. In the case of single linked list, you cannot do that. You can only check that to which node it is pointing, but you cannot check that whose node who are pointing to it. So that logic is correct, Monu, but good try. Everyone take another try. I want some answers, okay, some answers which you may think. Try to imagine this, guys. Nithilakshmi, I'm expecting an answer from you also. And all those students who always give answers correctly. Can you tell me? Anyone? Or tell me, I will explain the answer, okay? If you need the answer, tell me, I will explain it. Quickly, we don't have time. We have to discuss the double circular linkage today only. Okay, so I'm explaining it what we can do. So we can do just a simple. Oh, okay, I've erased the whole thing. So can we store it? Just let me draw it. In the place of eraser, I have pressed erase all. So this is one node, this is one node, this is one node, and in another list we have some nodes, and this, suppose this list is intersecting with the second list. This is pointing to null, and we have some elements. So we have two head 1 and head 2. We have element 1, 2, 3, let us take 4, 5, 6, 7, 8 and 9. You have to tell the data stored at the intersecting node. So Jasmeet is telling that can we store data of second linked list in array and traverse the first linked list. So yes, that is also correct, Jasmeet. Very good approach. But suppose if you have similar elements, okay, if you have similar elements, suppose this answer should be 8, but if you have a 8 here, and what you will do, suppose if you store h1 in a particular array, and if you search, sorry, if you have 8 here also, then you will get wrong answer. Yes or no? So what I am going to do, okay, so simple thing which I am going to do, I am going to take two references, first A and second reference as B, and I am going to iterate while this h1 not equal to null or h2 not equal to null, or one more thing, that is the answer only. So one more thing we have to check, or this A not equal to B. You can see in both, in this while loop what we can do, A is equal to A dot next, and we can do B is equal to B dot next. So when this will stop? Only this will stop if both the linked lists are either not intersecting, or it will stop when we can see at this situation A will be also pointing to this 8 node and B will be also pointing to this node. Now sooner they both are equal, this loop will stop. Yes or no? Now can we just print A dot data? This is our intersecting node. Yes. Or we can also check if h1 not equal to null. After this entire loop, if this h1 not equal to null and h2 not equal to null, then we can print what? Then we can print the data stored in A dot next, or we can also A dot data, or we can also print B dot data. Tell me yes or no, are you getting this logic? Quickly, anyone? Jasmeet, did you get this? Nithilakshmi. Cool. So these type of questions are, lots of these type of questions are available on Geeks for Geeks. You can check that. I will also give you the link. I think I've given you the link. So now let us move to the next linked list, which is circular double linked list. So this is a combination of what? This is a combination of circular linked list as well as double linked list. Yes or no? So in this case of circular double linked list, it is exactly same as the double linked list. Just one difference is there, that it is that the end of the given list is linked back to the front. So first let us draw a double linked list. So this is head, this is first node, this is second node, this is third node, and this should be pointing to null in a double linked list, and this is pointing to previous, this is pointing to previous, this is pointing to null. Now when we convert this double linked list into a double circular linked list, this null should, okay, we have a tail also here, so this null should be pointing where? This null should be pointing to this head, and this null, that is head dot okay, so we have three compartments, and head dot previous should be pointing to where? The head dot previous should be pointing to the tail. So these two references we are having as extra. So what I'm going to do, I'm just bringing the code already written and I will explain it to you. Okay, so that will save our time. So I'm creating a class. Let me call it as double circular, okay, double circular uh, linked list. Done. And I have a code in my Notepad++ where I do the hit and trial thing. So okay, these code, all the codes are originally written by me only. I have not taken it from anywhere. What I do, I just create nodes and I do hit and trial methods. So I've written these codes in my third year, I think. I have studied from the Geeks for Geeks platform, and then I've tried to create this. So in the most basic way, I've written this to get a proper idea. So yes, we have taken this as copy, and we are having it here. So the name is the same. It is double circular linkage. Let me check the comments. Okay. So now we have the head reference, we have the tail reference. This thing we have. Let me have the whiteboard again at the same time so we can. Okay, let me close this. So we can discuss the logics. Now we are having three compartments: one for data, one for next node, one for previous node. Okay. Now what we are doing in node, in insertion of element at front, you can see if the head is null, what we can do. If this head is null, how we can insert element at front? We can add the new node. So we can do head is pointing to the new node, and we can what we can do? We can point tail as also to the new node. Check the code also. Okay, we can point tail also to the new node. Previous will be pointing to tail, isn't it so? So you can see we have written tail dot next is pointing to head. Even tail and head are similar. Why I am writing like this? So you can head dot previous should be pointing to tail, and tail dot next should be pointing to head. Is there any confusion? Just tell me. So this is when the head is null. Now in all other cases we are performing this operation. So let us discuss this. So in the case our head is not null, means we have some element. Suppose we have a single element, how our linked list will look? Double circular linked list. So since we are having three compartments, okay, let us take two. Okay, let us take two elements. Now this is pointing to here, this is pointing to previous. Now this is pointing to here, and this is pointing to previous node, and this is our tail. Any more thing? So no, we are having data 1 and data 2. Now we have to create node. So let us see. Now let us have our new node here only. So this is our new node. Let us have our data 3. Initially these are pointing to null. Now what are the links which we are going to change? You can see new node dot next is equal to head. So this is pointing to head, since we have to insert at head. Okay, we have to insert here. Now what we have to do? Head dot previous is equal to new node. See, we are breaking this reference head dot previous and we are pointing it to where? We are pointing it to new node. Now why we are doing that, I will explain you when I will reconstruct this diagram. Now head is equal to new node because this is our first element. So head is equal to new node. Now tail is equal to tail dot next is equal to new node. You can see the next of tail should be also always pointing to the head. So we can also say tail dot next is equal to head, or we can say tail dot next is equal to new node. Both are doing the same thing. Now one more thing we have to do, new node dot previous is equal to tail. So let me draw it here. Just a second. So this should be yes or no. Let me show you. If this is so, this the new node is D3. Okay, so new node is D3. We are already having D1 and D2. So D3 dot means new node dot previous is equal to tail. It means what? This is our tail, and the previous means new node dot previous is equal to tail. And you can see we are having tail dot next is equal to new node, means this is pointing to the new node. Okay, and these operations which we have done earlier. So this is how we can insert element at the front. Making sense or not? So now I think these operations are clear. How we can insert element. So these codes are what? These codes are combination of double linked list as well as single circular. So you can that later also. Okay, these are just combination. We are the head is null. We are set of operations. Means there is no element. We are adding a fresh element in the node in the head. So this is same. Now this is in the case we are going to insert element at the end. So let us take a double linked list. So let us have this one element. This is second element, and this is pointing to this. 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 This is the tail. Now we are previous. Now this is pointing to now. Is this clear? Means is this visible? The screen and the code. Give me yes or no. Cool. So yes, this is how we can insert in the middle. Now how we can delete? So if this head is null, we can return, or if this head is equal to tail, means if there is only single element, what we can do? We can dereference head and tail. So this is how we can delete if there is only single element. Otherwise, if we have more than one element, so we can perform the operation of deleting the first element. Okay, so we are doing head is equal to head dot next, tail is equal to tail dot next is equal to head. Means we are updating the tail with the new head. and we are updating the previous of the head as tail. So this is how we are eliminating the element at the head. Otherwise, what we can do, we have to search that element. So we are iterating using temp is equal to head. Okay, and if this temp is not equal to tail, it means what? Found at middle. Otherwise, if that temp is equal to tail, so when it is found at middle, we are doing previous dot next is equal to temp dot next dot previous is equal to previous. So these things, these are simple things. Now I think we have practiced many times. Now else if this temp is equal to tail and data is also matching, what is the condition? The condition is that we are found at the tail. So in that situation, we are deleting the element at tail. So previous dot next is equal to temp dot next, because temp is equal to tail. So this temp dot next is nothing but the head again, and temp dot next dot previous means the head dot previous, we are pointing to previous, and the last element is now previous only. So tail is equal to previous. In all other cases, we are printing not found. Now deleting at an index, same thing. If the head is null, we are returning. If it is first element and there is only single element, we are dereferencing head and tail. Otherwise, if the position is 0, we are performing these operations. These are just same thing which we have done above. Otherwise, we are iterating and incrementing count variable, and if this count matches with the position, you can see at that point when this count matches with the position, this loop will stop. And if we have reached the head, it means what? The index is invalid, because while it is a circular, so we'll again reach the head. So in this situation, that index is not present. Otherwise, it is tail, so we can do the operations for tail. Otherwise, it is in middle, we can do the operations for middle. So these are obvious, you can check that later. Searching the first matching element. For searching the first matching element, if head is null, there is no point that the element should be present. It means the head, the linked list is empty, so we are returning that not found. Otherwise, we are iterating using count and we are incrementing count. Since we are why we are using count, we have to return the index at which index the element is found. For that, we are using count. If last not equal to tail, means if it has not reached the tail, it means what? The element is found in the middle, so we can print. Otherwise, if the last is equal to tail and the data is also matching with that tail, it means what? Found at tail. In all other situations, it is not found. Now, for the head, we have already taken. Now, printing the list is just the same thing which we did. Okay, so for printing, we have iterated till the tail, and for the tail element, we have added this extra statement, that is no dot data. In again the same thing, while reverse traversing, we will not reach head. Okay, when we will reach head, this operations won't be performed for head. So we are again printing the data present in the head. Yes or no? So if you take a look at this code, you can easily understand. So just now we have done these operations, reverse traversing and forward traversing in circular linked list. In double linked list, not circular, in double linked list. Now let us try out these operations. So I'm just running this and let us check if it works or not. So I am entering a value 1. Okay, I'm entering 1 again. I'm entering 2, again I'm entering 3, again I'm entering 4. So it should show 4, 3, 2, 1 because we have inserted at the beginning. So I'm printing 6, pressing 6, so it is showing 4, 3, 2, 1. If I press 7, it should show 1, 2, 3, 4. So yes, it is working fine. Now if I insert after element, let us insert after 2. So for that I am pressing 3 and I am pressing the element 23. I want to insert it after the key 2. So now let us check. So yes, it is inserted after 2 successfully. In the both iterations, you can see reverse and back, it has inserted after 2. Now let us search for deleting. So yes, you can try out this later. So I want to delete the index 5. Oh, okay, let us take it 4 because index starts from 0. Now let us show you 6. I can see only 4 elements are left. Okay, and if I do reverse traversing also, it should show 23, 2, 3, 4. So yes, it is correct. Now for searching an element, let us press 8. Let us search 23. You can see it is found at index 3. Why? So this is reverse traversing. So this is forward traversing. So index 3 means it is present at the last index. Again, you can do 9 for terminating. So this code is working fine. And let us discuss the operations. So just a second, where is my pen? Okay. So for creation, okay. So for creation, again same things we have. iteration is 1 and space complexity is 1. These are n, these are n, these are n, these are n. This is big O of 1. You can in some cases you can tell big O of n, but I am teaching it as big O of 1 only. So this is same as 1. So now I hope that you have understood all the linked list. Okay, I know that I have completed it in a very speedy manner, because you can see all the linked lists are related. All the linked lists are all types of linked lists are almost similar. Just with a small changes in one code, we can change one linked list to double, circular, and other types. So now let me show you one thing, that how you can practice questions. Okay, some practical uses of linked list. Let me tell you. So can you tell me in real life where we have linked list? So just now I've already given the answer. In real life, in technologies where we use linked list, can anyone tell me? Let me check how many of are in the class. You can see 7. Okay, so just now I have given the example. You can see when I am traversing between the tabs which are open in my system, you can see I can traverse forward and I can traverse backward also. As well as you can see when I am traversing the first tab, if I traverse back than this, you can see I am reaching the last tab. This is an example for which type of linked list? I know everyone can tell me. This is an example for which type of linked list? I can traverse forward, backwards, as well as when I reach the last node, I am coming to first node. When I am reaching the first node, I am coming to the last node. Anyone? So this is an example for double circular linked list. Yes, making sense or not? You can see because it is circular. When I am traversing, there is you can press Alt Tab. Okay, if you press Tab and Alt, you can see this is present. And if you keep pressing Alt and press Tab one by one, you can traverse in the forward direction. So this is a linked list type of structure. Okay, this is created using linked list concept. Now next example is traversing between photos in an image viewer. Okay, if you use image viewer in your mobile or in your laptop, you can see you can traverse between photos in forward and backward direction. Same thing, you can traverse between songs in a music player. Okay, you can go to the next song, you can go to the previous song. Now in online exam, so some situations are there that what you are restricted to move to the previous question, so you cannot go to the previous question. So that is the implementation of which type of linked list? In some exams, after completing one question, you cannot go to the previous question. I know you can tell this. Anyone? Cool. So just everyone is correct. It is an example of single linked list because we can traverse only in one particular direction. So these are some examples, and from tomorrow we are going to start STAT. So let me show you just that you can go to Geeks for Geeks. Okay, and in the courses, not courses, in the tutorial section, you can see free materials are here. Okay, you can go to linked list, and here you can see lots of questions are there. So that first we have the basics kind of things, introduction. Now search an element in a linked list using iterative and recursive concept. Write a function to get nth node in a linked list. These are nothing but searching kind of things. Removing duplicates. These are interesting questions. Okay, removing duplicates from a sorted linked list. So let me show you how you can study. You can go to that question. You can read this question. This is the question. Then you can understand what is the algorithm he is trying to follow, and you can try to implement. If you are having trouble in implementing that algorithm, you can go to this Java code. You can see almost similar thing is there. Okay, just we have done how it is doing in the same way. It is taking int data node, and it is taking also a constructor, and this is how it is taking up. It is creating a function. All right, and from the main block, everything is it is done. So you can read this, and if you have a trouble, you can, I think, for not for all questions, but for the difficult questions, you have a video attached at the bottom, and you can see multiple codes are there. So they will try to improve the implementation. Okay, another approach, you can see another approaches are there. So in this way, you can do some good questions. They are good level questions. You can see for circular linked list, if you only do the 16 questions, that is enough for a service-based company. For double linked list, you can see 27. You can also go to more sections, but if you are done with these 27, try to do next for other data structures also. If you are completed with all the data structures, then you can go to more sections for everything. So yes, these are some questions, and you can see videos, quizzes on linked list. So from quizzes, you can practice the MCQ questions. So yes, with this we have completed Any questions, tell me. If you have any doubt, just ask. Otherwise, I will end this class. I know everyone is hungry. I am also hungry. So we'll have our dinner. Okay. So yes, thank you for listening with so much patience. From tomorrow, we are going to start the stack, and the stack again can be implemented using either array or a linked list. But I am going to follow linked list implementation because it is more efficient, okay, and easy to understand, as well as we will not have a memory problem in stack. There will be a memory problem if we do using a what we can say array. But if you do using a linked list, the memory problem won't be there. So yes, thank you for listening with so much patience. Let us meet tomorrow. Good night. Good night. Good night, everyone.